Assalamualaikum and hi. So today we are going to present our assignment titled Radar System, and our group members is Runieza, which is myself, Nur AMIRAH, and Muhammad ZHAHIN. This assignment was supervised by Dr. Muhammad Ta'ari Muhammad Isa. This is the things that we will explain in this presentation. The first one is introduction, and the second one is literature review. The third one is methodology. Next is result, discussion, and lastly was the conclusion.
Okay, for the abstracts, advancement in electronic components and signal processing methods have led to miniaturization and cost reduction in radar systems. Migration to higher frequencies in the millimeter and terahertz domains has also become possible. The electromagnetic spectrum is becoming more valuable and tightly controlled resource. Radar system must be able to manage more signal bandwidth and maintain high receiver sensitivity while competing with other systems for some resources. Coexistence technique must have developed to ensure that performance is not degraded. Okay, for the introduction, radar system use radio wave to detect and track objects. They consist of transmitter, receiver, antenna, and signal processing equipment. The transmitter sends out a high-frequency RF signal, which is reflected off object and detected by receiver. Signal processing equipment analyze the reflect signals to extract information about the object, range, velocity, and position. Radar systems have wide range of application including air traffic control, military operation, weather forecasting, navigation, and more. Modern radar technology has advanced significantly and is able to operate at higher frequencies and with greater accuracy and precision than earlier systems. Next is for literature review. Henry Hertz was the first to gather experimental evidence for the existence of electromagnetic waves and found that radio waves are reflected by metallic surface. Christian Pulsmeyer was the first to conduct the radar detection experiment in 1904 using Hertz reflector and developing the telemobiloscope, and was granted a patent for the technique, making him the creator of radar. The Doppler effect, which is important for determining the motion of a detected object using radar, was also discovered during radar's development and is named after the Austrian physicist Christian Doppler. Radar was developed by military usage before World War II, initially using low frequencies around 60 MHz, but advancement in technology and the use of magnetrons have increased the frequency range to higher levels. High and microwave frequencies are used with shortwave like narrow beam antennas to improve radar's ability to identify targets.
So next is for methodology part. We know radar operates on a very simple principle because it transmits electromagnetic power while always analyzing the energy returned to the target. If the return signals are received at their original location, an obstacle is in the way of transmission. So this is the diagram for radar system. Okay, so next, I will explain the function of the radar system block diagram. Okay, so the first one is power supply. The power supply provides the electric power for all the components and it will supply typical amount of power consumed, not the high power level during the particular pulse transmission. Next is synchronizer. The synchronizer will sync the range determination timing, and it will send the signal along with the transmitted signal to know the return sweep and display the signal. The next one is transmitter. Transmitter will create the radio wave to be sent and modulates it to form the pulse train. Transmitter also enhance the sign to a strong level to provide sufficient reach. The next one is receiver. Receiver is sensitive to the range of frequencies being transmitted and provides amplification of the return signal. It is to supply the best range, the receiver must be very sensitive without introducing excessive noise. The next one is the duplexer. Duplexer acts like a switch between the transmitter and receiver. It was used to protect the receiver from the high power output of the transmitter. During the transmission of pulse, duplexer will align for transmitter, and after pulse send, the duplexer will align antenna to receiver. And the last part is for antenna. Antenna acts as a mediator between the system and air. It takes the radar pulse from the transmitter and put it into the air. Also, it takes the reflected wave from the air and put it into the receiver. And antenna also used in the radar system are highly directional with low beam width. Next is for the result. So this is the coding that we have done in MATLAB. So for the first part is to define the parameters, which is for frequency, pulse duration, and antenna gain. Next is for this part is to generate and plot the signal for pulse signal. The third part is to define the radar cross-section of an object between the radar and target object. Okay, so next is to calculate the Doppler shift and range using the radar equation. Next is we use this coding to generate the signal received at the radar antenna. And for the last part is to plot the signal received. So the next one is the waveform and the workspace. As you can see, when we run the simulation in MATLAB, when we run the coding in the MATLAB, we can see this output of waveform for the radar system, and this is the output for the workspace. We can see the value of the things that we have key in the coding.
Okay, this is our discussion. Okay, as a conclusion for project, radar is often used to identify an object velocity, range, and position. The benefit of a radar is include in enhanced penetration capability and any kind of weather. For the project, we know the basic operation of radar system. A transmitter produces an electromagnetic signal, which is then transmitted into space via antenna as a part of the system. When the signal interacts with an object, it may be reflected or radiated in different directions. The radar antenna then gather the reflected or echo signal and is sent to the receiver, when then it processed to determine the target location. The range then determined by timing the signal journey from the radar to the target and back. The angle between the antenna and the direction of echo signal with radius amplitude is used to locate the target. Direction and the location of moving objects are determined using the Doppler effect. That's all for our group.
So that's all from us. Thank you.